All right, today we're going to take a look at a really stunning galaxy called NGC 5866. You probably know it as the Spindle Galaxy. And yeah, it is absolutely gorgeous, but as we're about to find out, its calm, beautiful appearance is hiding a pretty wild cosmic secret. So, let's dive in.
And there it is, just hanging out in the constellation Draco, about 47 million light-years away from us. Because we see it perfectly edge-on, it looks like this glowing lens floating in space, sliced right through the middle by that sharp, dark lane of dust. It just looks so peaceful, right? Almost frozen in time. A perfect picture of galactic calm.
But, looks can be deceiving. Because when astronomers looked at this galaxy, not just in visible light, but in X-rays, they found something that, well, it just didn't make any sense. It completely flipped the script on their understanding of galaxies like this one.
So to really get why this discovery is such a big deal, we first have to understand what scientists thought they were going to find. What kind of galaxy is this Spindle? And why did everyone assume it would be so quiet?
Okay, so NGC 5866 is a type of galaxy called a lenticular, or S0. You can think of them as a kind of hybrid, somewhere between a spiral galaxy and an elliptical one. They've got a disk and a bulge, but no spiral arms. Now, the key thing here is that they're often called red and dead. Why? Because they've pretty much used up all the cool gas they need to make new stars. Basically, they're supposed to be galactic retirement homes. Quiet, calm, not a lot happening.
But the very first hint that something was off about NGC 5866 was right there in the picture, hiding in plain sight. It's the one feature that makes the galaxy look so amazing to begin with. I mean, just look at that incredible dust lane. For a galaxy that's supposed to be poor in gas, that is a ton of dust and cool material. And what's really cool is, if you look super closely, you can see these weird little dusty spurs and filaments just reaching up and out from the main disk. It begs the question, in a supposedly retired galaxy, where did all this stuff come from? This was the first major clue that the Spindle Galaxy wasn't nearly as sleepy as it was supposed to be. Okay, so that dust lane was weird enough, but the real head-scratcher came when astronomers switched their view from visible light to X-rays. They were hunting for the super-hot gas that should be filling a galaxy like this, a halo that's been heated up over billions of years by exploding stars. They had a pretty simple theory of what they'd find. A straightforward story of stars heating up the galaxy. But what the telescope actually showed them, whoa, that was a whole different story. A much, much stranger one. And here's where it gets really wild. See, the galaxy is full of dying stars, especially these exploding white dwarfs called Type 1a supernovae. All those explosions should be heating up the gas around them to about 1 million degrees. But when they measured the temperature of the gas halo, it was only about a quarter of that. It was way, way too cool. Seriously, it's like expecting a furnace and finding a lukewarm radiator. Where did all that heat just disappear to?
And then, clue number 2 dropped. Take a look at this chart. You see that big cluster of galaxies all hanging out together down at the bottom? Now, look way, way up at the top right. See that one lonely triangle? Yep, that's our galaxy, NGC 5866. Its halo is absolutely packed with iron, way more than pretty much any other galaxy of its type. So now we have this double whammy. The galaxy is too cool, and it's suspiciously loaded with iron. What is going on?
So you've got these two clues, right? The missing heat and the extra iron. At first glance, they sound like they totally contradict each other. But it turns out they're not separate problems at all. They're actually two pieces of the exact same, really elegant cosmic solution. Okay, let's walk through how this works. It all kicks off with those Type 1 supernova. They're basically cosmic iron forges. When they explode, they shoot out these huge clouds of superheated iron-rich gas. Now, in most galaxies, that hot, fast-moving gas would just blast right out into deep space, lost forever. But not here. In NGC 5866, that hot gas slams right into the cold, dense gas in that big dust disk we saw earlier. That collision works like a giant cosmic radiator. It radiates heat away incredibly fast, cooling the hot gas down almost instantly. And because the gas is now cooler, it's also a lot slower. Slow enough for the galaxy's own gravity to grab onto it and keep it from escaping. So that dust lane? It's not just a pretty feature. It's a cooling system and a trap. And boom, here is the money shot. This image shows you exactly what's happening. The blue stuff, that's the hot X-ray gas we've been talking about. The red and green shows the cooler material, the stars, and crucially, that gas and dust in the disk. You can literally see where the hot halo is mixing with the cool disk. This is it. This is the cosmic radiator in action, solving both of our mysteries in one beautiful picture. The interaction cools the gas and it traps the iron. Perfect.
So, what's the big picture here? What does solving this mystery actually tell us? Well, it completely rewrites the story of the Spindle galaxy, and probably a whole lot of others just like it.
The biggest takeaway here is that these galaxies we used to dismiss as red and dead are anything but. NGC 5866 is this incredibly dynamic living ecosystem. It's actively circulating material between its disk and its halo. That dust lane we thought was just the puzzle turns out to be a vital piece of the engine, allowing the galaxy to capture and recycle the heavy elements created in its stars. So the Spindle galaxy isn't dying, it's actually enriching itself, holding on to its own chemical legacy for billions of years.
You know, this whole discovery just goes to show you that the universe is always way more complex, more clever, and more interconnected than we give it credit for. A feature that just seemed like a simple puzzle piece turned out to be the key to the entire machine. And it really makes you wonder, right? If a supposedly quiet, retired galaxy is this active and full of life, what other incredible secrets are still waiting for us out there in the dark?